In a previous lesson, you learned one way to solve a system of linear equations by simply adding the two equations together. Sometimes that won't always work directly. If you look at the two equations we have here on the left, the coefficients of either the x variable or the y variable are not opposites at the beginning. So we've got to do an extra step in this method in order to get the coefficients to be opposite. And in this case, as the example is showing, if we were to look at the first equation and simply multiply it by 2 on both sides, which we're allowed to do, we'll change it to some other equation which is equivalent to the first one. That's always important that they stay equivalent. But look how the coefficient of y has changed. It's changed now to 4y, which is opposite from this coefficient, which is negative 4. So if we were to finish this problem the way it is here, we could simply add the two equations together, as you learned in a previous lesson. 10x plus 3x gives you 7x. Ten x plus 3x gives you 13x. The plus 4y added to the negative 4y, those are opposites, so they cancel to 0y or just 0. And on the right side of the equal sign, when we add 32 plus 20, we get 52. We've now changed the system to just one rather simple equation, and we can solve this by dividing both sides by 13, so x is equal to 4. The remaining part of the problem is something you've done several times. We won't do it right here, but you would simply take x equal to 4, go back to one of the original equations, that's always stressed, use the original equations, and substitute 4 for either this x or for this x. And then you could solve that equation for y, giving you the ordered pair for the solution. So let's look at another one. In this example, here's our system of equations. The first thing I want to look for is, do I have these written in standard form? ax plus by is equal to c. I do. And the second thing I want to look at is, are the variables that are the same, in this case the x's, are they lined up? In this case the y's, are they lined up? They are. So we're ready to proceed. So the first thing I might look at is, are the coefficients of either one of these variables opposite? Well, they're not. So what we're going to have to do is we're going to have to choose one of the equations, and maybe both, multiply it by some number, so that when you multiply through, the coefficients will be opposite. What we can do is we can eliminate either the x variable or we can eliminate the y variable. It's your choice, whichever seems to be the easiest for you. We'll do both of them here to demonstrate that it really doesn't matter what you choose. So on the first one, we'll concentrate on eliminating just the x. So I'm looking at the two x terms. I have 6x and 2x. The question is, what could I multiply either one of these by so that the x's will be having negative or opposite coefficients? Well, one choice is to take this 2x and somehow change it into negative 6x. I can do that easily by multiplying both sides of the equation. We like to draw parentheses around the whole equation, and on the outside put parentheses to indicate multiplication, and then ask what am I going to multiply 2x by so that it's the opposite of 6x? Well, that's going to be negative 3. I do it on both sides so that I don't forget to multiply both sides. I like to draw a separator line here. And then you distribute in the negative 3 just as if you're multiplying both sides of the equation by that number. So it's a good habit to rewrite the whole system. So I'm simply at this time rewriting the first equation. That's going to remain unchanged. And the second equation changes to negative 3 times 2x, which is negative 6x. Go back outside and distribute in the negative 3 times the positive 3. That's a negative 9y. And multiplying the other side by negative 3 is negative 15. What I've just done is created a new system. The first equation is the same, but the second equation is equivalent to the second equation that we started with, and we can now work on this system to solve it. So because the coefficients of x are opposite, I can add the two equations together. I like to put a big plus sign out here to remind me of that. And so 6x plus negative 6x, they cancel, giving me 0x. 5y plus negative 9y is negative 4y. And 19 plus negative 15 is positive 4. If I divide both sides by negative 4, that'll give me the solution for y, which is negative 1. At this time, we go back to what we're familiar with when we get the solution to one of the variables. We take y and we substitute it back into either one of the original equations. You get to choose whichever you find easiest, and then you solve, in this case, for x. So we'll go through that last step. I think I'm going to go back to the second equation and let y be replaced with negative 1. So I have 2x plus 3 times y, which is equivalent to negative 1, is equal to 5. And I have one equation, a rather simple one, with one variable, x, so I can solve for x. That gives me 2x minus 3 is equal to 5. I add 3 to both sides, giving me 2x is equal to 8. Divide both sides by 2, and x is equal to 4. So my two values for x and y, x equals 4, y equals negative 1. We summarize the problem by writing the ordered pair for negative 1. Good. Well, let's do the same system, but this time we're going to focus on eliminating y. So when I look at the two y values, it's not immediately clear what number to multiply one of these equations by. It could be done, but it would end up to be a fraction. So one option is to find two numbers that when you multiply both equations by the numbers you choose, you can eliminate y. Well, one of the easiest ones to multiply by, if I can get both of these to be 15, and one of them negative, one of them positive, that would cancel out the y's. So I'm going to choose to multiply the first equation by negative 3. That would change 5y when I distribute in negative 3 to negative 15y. Remember to do it on both sides. Those are important habits to remember. And the second equation, I'd multiply that by a positive 5. So now let's rewrite the new system after I multiply by these two numbers. So distributing in negative 3 times 6x, negative 18x. Negative 3 times 5y, negative 15y. That's what I wanted. On the right side of the equal sign, negative 3 times 19 is equal to negative 57. Doing the second equation, distributing the 5 times 2x is 10x. 5 times positive 3y is positive 15y. There's my opposite coefficient, just what I wanted. And on the right side, 5 times 5 is 25. So now I've got an equivalent system of equations with the y variables with opposite coefficients. So now when I add these two equations together, I get negative 18x plus 10x is negative 8x. The negative 15y added to the positive 15y is 0. And negative 57 plus 25, that gives me a negative 32. I now have reduced the rather complex system of equations to just one equation with one variable, x. I divide both sides by negative 8 to solve for x, and x turns out to be a positive 4. Since we're just doing this example to verify that we can choose either variable to eliminate, I've come to the conclusion that x equals 4, which is what I discovered the first time through. At this time, it wouldn't be necessary to again show that y equals negative 1, but it would, obviously, if I substituted x is equal to 4. Good. At this time, I will stop here, and when you come to class, we'll continue working on this new method of elimination by multiplying one equation or both equations by some number in order to eliminate the variable.